Trigonometry often feels like navigating through a maze of angles and sides. Thankfully, we have tools to guide us. One such tool is the Law of Cosines. This law is crucial for understanding the relationships within all triangles, not just right triangles. It expands on the famous Pythagorean theorem, allowing us to tackle a wider range of problems. Imagine you have a triangle, and you know the lengths of two sides and the angle between them. This is where the Law of Cosines comes in handy. It provides a formula to calculate the missing side. Conversely, if you know all three sides, you can use this law to determine any of the angles. This ability to connect sides and angles makes the Law of Cosines a cornerstone of trigonometry, with applications in fields like navigation, engineering, and even computer graphics. Let's delve deeper into this fundamental principle. The Law of Cosines is expressed in three forms, each focusing on a different side of the triangle. However, they all stem from the same core concept. Let's examine one of these forms. C squared equals a squared plus b squared minus 2ab times the cosine of c. In this formula, c represents the length of the side opposite angle c. A and b are the lengths of the other two sides. C is the angle formed by sides a and b. Notice the similarity to the Pythagorean theorem, a squared plus b squared equals c squared. The additional term, minus 2ab times the cosine of c, accounts for the angle c not being a right angle. The other two forms of the Law of Cosines simply rearrange the equation to solve for a squared and b squared, respectively. The Law of Cosines isn't just a formula pulled out of thin air, it has a solid geometric proof. Draw a triangle ABC, labeling the sides A, B, and CE. From vertex C, draw a perpendicular line to side C. We now have two right triangles. Apply the Pythagorean theorem and trigonometric ratios. After simplification, we arrive at the Law of Cosines. Section 4. Finding missing sides, applying the law. The most common application of the Law of Cosines is finding the length of a missing side. Let's say we have a triangle where side A equals 5 units, side B equals 7 units, and angle C is 60 degrees. Our goal is to find the length of side CE. We can plug these values directly into the Law of Cosines formula. C squared equals a squared plus b squared minus 2ab times the cosine of c. So, c squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 60 degrees. That simplifies to c squared equals 25 plus 49 minus 70 times 0.5. So, c squared equals 39. Therefore, c equals the square root of 39. The length of side C is the square root of 39 units. The Law of Cosines allows us to solve for an unknown side when we know two sides and the angle between them, which is the SAS case. Section 5. Unveiling angles, the inverse cosine. The Law of Cosines isn't limited to finding sides. We can rearrange the formula to solve for angles. Let's say we know all three sides of a triangle. Side A equals 8 units, side B equals 10 units, and side C equals 12 units. To find angle C, we can rearrange the Law of Cosines formula to solve for the cosine of C. Cosine of C equals a squared plus b squared minus c squared divided by 2ab. So, cosine of c equals 8 squared plus 10 squared minus 12 squared divided by 2 times 8 times 10. That simplifies to cosine of c equals 64 plus 100 minus 144 divided by 160. Cosine of c equals 0.125. To find the angle c itself, we use the inverse cosine function, also known as arcos. So c equals arcos of 0.125, which is approximately 82.8 degrees. Therefore, angle C is approximately 82.8 degrees. This demonstrates how the Law of Cosines provides a way to calculate angles when we know the lengths of all three sides. Section 6. Practical applications, Law of Cosines in action. The Law of Cosines proves its worth in various real-world scenarios. Let's explore a couple of examples. First, navigation. A ship wants to determine its distance from a lighthouse. It knows its distance from two other points on the coast and the angle between those points from its perspective. Using the Law of Cosines, the ship can calculate its distance from the lighthouse. Second, engineering. An engineer designing a bridge needs to calculate the length of a support beam. The beam forms a triangle with two other beams whose lengths are known, and the angle between them is fixed by the bridge's design. The Law of Cosines provides the solution. These are just a glimpse into the practical applications of the law of cosines. Its ability to bridge the gap between sides and angles makes it an indispensable tool in numerous fields.